In 1982, a spacecraft touched down on Venus, its instruments working hard to gather invaluable data. Every passing second was a race against time in the harsh environment. Then, after a record-breaking 127 minutes, the longest a lander has ever survived on this planet, the signal from Venera 13 suddenly stopped, lost in Venus's tough landscape. This bold mission by the Soviet Union, despite facing immense challenges, provided us with a brief but insightful look into a world that has puzzled and escaped our understanding for years. The first real images of Venus were nothing short of astonishing. Venus has long remained an enigmatic sister planet to Earth, seemingly similar in size, yet covered in clouds of sulfuric acid that betray the volatile world lurking beneath. While Mars, Jupiter, and even far-flung Pluto have opened their secrets to robotic spacecraft from Earth, Venus remains the least explored of our planetary neighbors. Often termed Earth's evil twin, Venus hosts crushing atmospheric pressures, scorching temperatures that could melt lead, and skies filled perpetually with dense clouds that don't even let a ray of sunlight touch the surface. This combination creates a planet so hostile that it has destroyed every probe sent to explore its surface. Some lasted mere minutes before surrendering to the planet's wrath. The biggest problem with Venus is its thick cloud cover. Unlike Mars and Mercury, we can't simply take pictures of the Venusian landscape from above. The clouds hinder our view. That's why we had to rely on radar mapping to learn about the geology of the scorching planet. But when the landers touched the planet's surface, they barely had enough time to capture and transmit what they saw on Venus. So, what views did we see beneath the thick cloud cover shrouding the planet? What do they tell us about the past of the Earth's evil twin? Finally, and most importantly, what secrets will the upcoming Indian, American, and European missions to Venus reveal? Just like Venus hides its secrets behind a thick cloud, in the digital world, your personal information should be kept hidden behind a secure shield. Speaking of shields, let me introduce you to the sponsor of this video, NordVPN. It must have happened several times that you really want to watch a movie for entertainment or a documentary for learning purposes, but it's not available in your region. For example, in my case, it was Nat Geo's Genius series on Einstein. NordVPN helped in virtually placing the device anywhere in the world and enabled access to this series. But that's not all. In today's digital age, spam and phishing attacks are more common than ever, posing real threats to your personal data. NordVPN adds an extra layer of security to keep those potentially harmful websites at bay. With just a single click, you can hide your IP address, making it tough for anyone to track your online activities. NordVPN even offers a 30-day money-back guarantee on all purchases, and if you use our unique link, nordvpn.com/secretsofuniverse, also in the description, you get a 2-year plan with a huge discount, plus 4 months for free. The journey to explore Venus started back in the 1960s. However, many of these missions faced setbacks and technical issues before they could even reach the planet. After the failure of 3 Soviet missions and 1 American mission to Venus, on 14 December 1962, a breakthrough arrived, with NASA's Mariner 2 becoming the first spacecraft to conduct a flyby of Venus successfully. Even though this mission lacked a camera to capture images of our earthly counterpart, it carried advanced sensors that yielded crucial insights about Venus. The information we gathered from Mariner 2 would play a central role in planning the next missions to Venus. One significant finding came from the radiometers, which collected infrared and microwave data. These measurements revealed the presence of dense clouds enveloping Venus and a searing hot surface. Infrared data suggested that surface temperatures ranged from 300 to 400 degrees Fahrenheit, 149 to 204 degrees Celsius, confirming Carl Sagan's prediction of a runaway greenhouse effect. Additionally, the mission discovered that Venus's atmospheric pressure was 20 times higher than on Earth, while magnetometer sensors indicated the absence of a substantial magnetic field. This lack of protection exposed Venus to constant cosmic ray bombardment, rendering it inhospitable for life as we know it. The Mariner mission served as the initial stepping stones for understanding Venus, but they marked just the beginning. Following Mariner, the 1970s ushered in the Pioneer missions, notably the Pioneer Venus Orbiter and Multi-Probe missions. These ventures significantly expanded our comprehension of Venus, highlighting its unique characteristics. In particular, Pioneer Venus 1 employed radar to map Venus's surface, providing scientists with a topographical layout for most of the Venusian terrain, spanning from 73 degrees north latitude to 63 degrees south latitude. This mapping was done with a resolution of approximately 47 miles. The combined data unveiled that Venus boasts a notably smooth and spherical surface, distinct from Earth. But the map also showed that it harbors a mountain surpassing the height of Mount Everest and a chasm that plunges even deeper than the Grand Canyon. The onboard cameras also caught glimpses of nearly continuous lightning discharges within the atmosphere. Meanwhile, the orbiter's ultraviolet observations unveiled elegant cloud formations that graced the Venusian sky. These insights were pivotal in expanding our knowledge about the composition and topography of Venus, offering a more intricate portrait of this enigmatic planet. The Pioneer Venus Multi-Probe mission, or Pioneer Venus 2, deployed 4 small probes into Venus's atmosphere on 9 December 1978. All 4 probes transmitted data during their descent. One of the probes impressively managed to survive its landing and sent data from the surface for over an hour. Pioneer Venus 1 continued transmitting information until 8 October 1992, when it eventually burned up in the Venusian atmosphere. This marked the conclusion of a remarkable 14-year mission, initially planned for just 8 months. But the U.S. was not the only country trying to unravel the secrets of Venus. In addition to the Mariner and Pioneer missions, another noteworthy series of probes greatly contributed to our understanding of Venus: the Soviet Union's Venera. The Soviet Union launched 28 spacecraft in the Venera mission to Venus between 1961 and 1983. Of these, 13 entered the Venusian atmosphere, and 8 successfully landed on the surface, achieving many firsts in planetary exploration. Despite early failures with Venera 1 and Venera 2 in the 1960s, subsequent launches made history. Venera 3 through Venera 6 conducted thorough atmospheric investigations, while Venera 7 achieved a remarkable feat by becoming the first spacecraft to land on another planet and transmit data back to Earth. Moreover, Venera 7 provided the first direct measurement of the Venusian surface temperature. But how did it do that? Well, there's an interesting story behind it. The landing module of Venera 7 was skillfully engineered to withstand immense pressures, up to 18 megapascals or 2,600 psi, as well as scorching temperatures reaching 580 degrees Celsius. It was equipped with both a small soil penetrometer and a thermometer. The mission utilized a parachute system to facilitate the lander's descent. As the parachute unfurled, atmospheric tests began, revealing that the Venusian atmosphere primarily comprises 97% carbon dioxide. However, a mere 6 minutes after the parachute was deployed, it began to malfunction, leading to the lander's uncontrolled descent. Consequently, the probe impacted the Venusian surface at a velocity of approximately 16.5 meters per second. During this event, the thermometer gauged the soil's temperature and transmitted this valuable data to Earth. The measurements indicated an astonishing surface temperature of around 475 degrees Celsius, 887 degrees Fahrenheit, verifying earlier indirect temperature estimations through infrared studies. Despite the parachute mishap, the probe continued to communicate with Earth for 53 minutes, with about 20 minutes of that duration originating from the surface of Venus. This achievement marked a significant milestone in planetary exploration and provided unprecedented insights into the conditions of another planet's surface. The Venera missions not only played an incremental role in measuring the ground temperature of Venus, but were also the first mission series ever to return the surface pictures of a planet other than Earth. In 1975, Venera 9 provided the first glimpse of the Venusian surface. This was the first time we saw the surface of another planet in the solar system. Although the spacecraft was well equipped with 2 lenses to capture a 360-degree panoramic view of the planet, one of the lens caps failed to open after landing, thereby leaving us with this 180-degree panoramic view of the planet's surface. The white object you see at the bottom of this picture is a part of the lander itself. One can see the dominance of rocks on the planet, with half of them partially buried in the soil amidst the mysterious horizon making its way in the upper right corner. In Venera 9's footsteps, Venera 10 also reached our twin planet the same year, with only one of the lenses separating and providing another 180-degree panoramic view of the Venusian surface. However, instead of spotting small rocks like its predecessor, Venera 10 imaged slabs of rocks analogous to volcanic areas found on the Earth. 3 years later, Venera 11 and 12 aimed to capture the colored images of the planet. Unfortunately, for both the landers, the lens caps failed to separate, which rendered them unable to capture any image. This spurred the mission teams to develop an alternative strategy, resulting in Venera 13 and Venera 14, the sole spacecraft to obtain colored images of Venus successfully. Upon Venera 13's landing on 1 March 1982, its lens cap was successfully ejected, enabling the cameras to capture the Venusian landscape in vivid detail for 127 minutes. A remarkable yet mystifying landscape emerged, featuring flat, dark, layered rocks with grain-like material filling the gaps. Just 4 days later, Venera 14 also reached the surface. However, it landed at a different location, where the land appeared even more fractured. Contrary to what was seen by Venera 13, there was very little grainy material. The yellowish sky above and the highly fractured surface underscored the planet's challenging and harsh nature. The Venera missions are primarily recognized for their temperature measurements and imaging. But little do people know that Venera 13 and 14 were also the first spacecraft to decode what a moment in our neighboring world would sound like. Both the spacecraft were fitted with microphones to record the sounds of Venus, and here's what was recorded. The only sounds you can recognize in this audio from Venera 14 are plain noise, the mechanical sound that the spacecraft made while drilling, and a few hints of the Venusian wind echoing in the background. Further analysis revealed that the wind speed is around 0.3 to 0.5 meters per second, which meant that the planet's dense atmosphere at the surface is surprisingly calm. As the Venera 13 signal blinked out, its record-breaking 127 minutes of data felt like a treasure trove and a taunting cliffhanger in our quest to unlock the secrets of Venus. Now, all eyes were on the Magellan mission. Launched on 4 May 1989, with a payload of high-tech radar, Magellan was poised to pick up where Venera left off. This wasn't just another mission, but the next chapter in an unfolding cosmic thriller. Magellan employed radar mapping techniques to generate high-resolution images of Venus's surface. It not only captured vast volcanic plains, impact craters, and evidence of past tectonic activity, but also provided stunning shots of some significant Venusian features. One such image, captured in November of 1990 during Magellan's initial orbit around Venus, unveils a region within Aphrodite Terra, one of the largest highland regions on Venus, spanning a significant portion of the planet's northern hemisphere. In the center of the image on the right, you can see a bright, flow-like area that can be seen extending to the west of a radiant fracture in the left image. It was concluded that a Venus quake might have produced this structure. So, this image by Magellan acted as the first evidence of active tectonics occurring on another planet in the solar system. Additionally, Magellan's radar unveiled Maxwell Montes, the highest point on the planet's surface. It's located near the planet's equator and rises about 11 kilometers above the Venusian surface. After the Maxwell Montes, Mont Mons is the planet's highest volcano. It's characterized by its broad, flat summit and gently sloping sides, which makes it one of the largest volcanoes in the solar system. Moving into the 2000s, a significant Venus mission was launched in 2005, known as Venus Express. This marked the first European expedition to study our neighboring planet in depth. Venus Express was an orbiter that studied Venus's atmosphere, clouds, and volcanic phenomena, while also confirming the presence of lightning, a phenomenon previously observed by earlier missions. Yet, what set Venus Express apart was its focused investigation into the planet's distinctive polar vortex. The story begins with the discovery of a gigantic hurricane with twin calm, dark eyes located at Venus's northern pole by the Pioneer Venus spacecraft in 1979. This discovery led astronomers to anticipate a similar vortex at Venus's southern pole. Therefore, when Venus Express detected a dual vortex structure at the South Pole in April 2006, it was perceived as confirmation of these vortex formations being consistent and permanent features. However, a surprise was in store. They actually changed their positions, transformed in shape, and eventually disappeared by 2009. This revelation shattered the notion of these vortices being stable on Venus. Instead, they turned out to be just one type of many atmospheric patterns. The data also highlighted a big difference in how the atmosphere behaves at Venus's poles compared to the rest of the planet. Exploring Venus with spacecraft poses many formidable challenges. The extremely high temperatures and pressures on the planet's surface are potent enough to crush most probes attempting entry. Moreover, the corrosive properties of Venus's atmosphere present challenges for spacecraft materials, electronics, and instruments. The effectiveness of solar panels, a common power source, decreases on Venus due to its thick atmosphere, low sunlight intensity, and high temperatures. Consequently, conducting advanced scientific investigations on Venus requires specialized materials and engineering solutions. Of course, it's difficult, but not impossible. And that's why Venus will host new guests from multiple space agencies in the coming years. In June 2021, NASA revealed plans to launch 2 missions to our searing sister planet by 2030. One of these missions, Da Vinci Plus, will comprise an atmospheric probe, while the other, Veritas, will be an orbiter. Veritas intends to employ radar technology to create a 3D map of Venus's surface, unraveling the planet's geological history, tectonics, and volcanic activity. Meanwhile, Da Vinci Plus aims to send a probe through Venus's atmosphere, meticulously studying its composition and dynamics. This mission promises insights into Venus's evolution, including the potential presence of oceans in its past. Besides that, other space missions to Venus include the European Space Agency's Envision, which will launch in the early 2030s, India's maiden mission to Venus, Shukrayan-1, to be launched in 2024 or 2031, and Russia's Venera-D mission, expected to launch by November 2029. These upcoming missions represent a renewed interest in studying Venus and better understanding its geology, atmosphere, and potential habitability. The missions would also show how an Earth-like planet became such a hostile world. Surely, many unexpected mysteries are bound to unfold in the upcoming years. Thanks for watching, and if you would like to support us, check out the link in the description for the exclusive NordVPN offer.